Hello folks. So this is our intro video for the chapter 4, class 11 computer science, the introduction to problem solving chapter. So in this chapter we'll be discussing what is a problem and how to solve it using certain number of steps and algorithms. So basically defining what is a problem. A problem is something, a task or a challenge that requires a well-defined and step-by-step solution. Right? The computers are not naturally smart. The entire rely on the human logic. The problem solving is identifying a problem, developing an algorithm, and writing a computer program in this context to execute it and have the output. So we'll go in the same procedure, the IPO principle. The input will be taken, some processing will be happening, and output will be at the end will be receiving. Our mission in this chapter is 4 steps. The 4 core steps will be problem solving and discovering, designing the logical algorithms, drawing standard flowcharts, writing clear pseudocode, and breaking down complex problems into shorter problems, that is the decomposition method. The first will be learning how to think like a programmer or a coder before writing any real code in any programming language. So we'll be following this framework, the cycle, the AACT, the first is analyzing the problem, means understanding what is actually given in the problem statement. Then is planning the logic to implement the solution, this algorithm, and coding and translating into a particular language, let's like Python. Then testing it and debugging it and fixing it. If it fails, again iterate over the same loop. That's all we'll be discussing in this chapter. Then here we have the analyzing the IPO framework. Like IPO, let's say if we from a doctor's perspective, the symptoms that we have, that's the input, and diagnosis the doctor is doing is the processing of what we do, and medicine is the output, that is what we want. Like that input in a mathematical form, let's say given data is length and breadth, you have to calculate the area, the length into breadth, you will be doing the processing, the math logic, and the output will be getting the area. So you have to understand the inputs, then you have to start the code. And the principle is here, garbage in, garbage out. Remember this. Then we'll be discussing designing algorithms using these characteristics for pure precision, uniqueness, finiteness, input, output. So what is this? What is the algorithm first? Algorithm is finite ordered sequence of well-defined instruction to solve a problem. So in precision, let's say the exact steps that we need. Uniqueness means relies only on the previous inputs. Finiteness means infinite loops should not occur and should stop somewhere. The stop case should be there, base case should be there. Inputs it should take and produce at least one result at the end. So these all things we'll be discussing in the video that will be upcoming later in the detailed explanation video of the chapter 4. This is just the intro here. We'll be doing the testing, debugging process after the coding process. Some bugs will be encountering to how to resolve that. Different types of errors we'll be discussing in this chapter. Tester is basically find the error. Debugger is basically the person who actually fixed the error, like the mechanic, and this is inspector. So don't get confused between these two terms. Then we go to the documenting logic in a flowchart format. Other is we have the pseudocode format. So in flowchart format, there's some graphically visual steps, and pseudocode is like text-based English like statements like these, right? And it is flowchart is seeing for the best for seeing the big picture, what is happening at the end, or branching the different parts, how here and there the mind map it is going. But in the pseudocode, it is quick to write and easy to translate into a typed code format. Modification, you have to redraw it again, the branching, logic changes, shape changes you have to do. But pseudocode, you just have to edit and rewrite the same thing, just like code, right? In line by line. And flowchart has strict standard geometric symbols are there which are fixed, where the pseudocode has no strict universal standard. So we'll be discussing this chapter what are the uses of all these steps. Like oval is for terminator, that is for start and stop of a program. Parallelogram is taking input from the user, printing the output to the user. Rectangle is for processing, math, logic, assigning, calculation, all these things. Diamond is for decision making, if else statement, yes, that will result in a boolean value, let's say yes, no, or true or false. Arrow lines are the flow lines, That is the strict direction it will be showing, multi-directional, unidirectional, bidirectional, how the logic flow will be going on. We'll be discussing this chapter some algorithm like how to check a number, if it is even or odd. Let's say we take a number input a and the start here and try and a equal to 7. If we do, if a modulo 2 equal to 0 means the remainder is getting 0, it is being actually it's a remainder is 0, then it's even number, else it will be in the odd number, then at least will be stop. Accordingly we'll be traversing all these things and now tracing all the algorithms like these in this chapter that will be upcoming here. And pseudocode will be writing like this, probably like input length, input breadth, compute area equal length asterisk breadth, and print area, then stop, and be converting later into this Python code. And we use some common keywords here to have it, like that is the informal plain English description of the program. Then flow of control, how it will be going sequential manner, selectional manner, sequential manner, it is a straight thing it will going, selection traverse how the branch is going, repetition again, iteration, just taking steps here. We're discussing all these flows will be discussing here, and some try run will be doing. What is basically try run? It is manually tracing the algorithm on paper in sample test values to know how actually the code actually works. And the benefits are that catches logical errors early, exposes missing edge cases, always the thing won't go in the happy path, right? And save hours of frustrating debugging later. And decomposition means how to divide and conquer, breaking a massive complex problem into smaller manageable problems. The why decompose overwhelming problems, tasks solvable, different teams can work parallelly at the same point of time, and specific modules can be tested independently, like the railway reservation system has many different models. There's a train information, there's a reservation information, about the staff, security, infrastructure information, billing service, food service, other details. These are certain things. And how do we choose the best algorithm? We'll see. And considering the trade-offs, especially the time complexity means how fast is it, lesser calculation are better, space complexity, how much memory does it use, the lesser memory use it better. Sometimes the trade-off, sometimes the faster algorithm uses the most memory, and it will and sometimes vice versa. If it is very slow, so it will be consuming the least amount of space. So then we have to consider trade-offs and see for what the optimized solution we have to choose it. So we'll be taking all these things in the next video probably, right? And some common mistakes that will be encountering in this chapter, some questions we'll be encountering. That's all of this document introduction video. Later stay awaited for the video that will be coming, the detailed explanation video of this chapter 4, class 11 computer science, introduction to problem solving. Stay awaited for the video, and that's all. And thank you for watching.